I'm going to use the example of the unicorn to help explain genetic mapping. In this example, the unicorn's horn, gold, is dominant to rainbow. The white stallion body is dominant to the black body, and the rainbow tail is dominant to the white tail. The coefficient of coincidence is going to be 0.98, and for the genetic map, the horn color to body color distance is 20 centimorgans, and the body color to tail color is 10 centimorgans. Now we need to determine what's the probability of crossover events. In this example, I mutated a purebred gold horn, white body, rainbow-tailed unicorn with a rainbow-tailed, black body, white-tailed unicorn. To determine the probability of a double crossover event, we need to take the region 1 centimorgan distance and the region 2 centimorgan distance, and then we need to multiply it by the coefficient. So we would have 0.20 times 0.10 times 0.98. That equals 0.0196. To find a single crossover event in region 1, that would take region 1 minus the double crossover event probability, so that is 0.2 minus 0.0196 equals 0.1804. For the double crossover events, the same thing as procedure for single crossover, but for region 2, so 0.1 minus 0.0196 equals 0.0804. And then for the non-crossover event, we take all of these three and we subtract it from 1. So then that would equal 0.7196. Now let's see what a double crossover gamete possibilities are. Now let's do a probability of gametes. In this example, we have a double crossover event where we want a rainbow-horned, white-bodied, white-tailed unicorn. So we need to take the double crossover event and multiply it by 1/2 because there will be 2 gametes generated, but we only want 1. That equals 0.0098. Now let's do the math for a single crossover event. So for this example, we want a gold-horned, black-bodied, white-tailed unicorn. So we take the single crossover probability of region 1, and then we multiply it by 1/2 because we want one specific crossover event, and that equals 0.0902. Here are the rest of the possible gamete types and their possibilities.